Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to go over an example problem of where you would need to use conversion factors to help you get the answer. So let's get into this. So in this problem we have the typical rate of deposit of dust from unpolluted air is 10 tons per square mile per month. And they're giving us a particular analytical balance, and it has a circular weighing pan of 8.00 centimeters in diameter. So then they ask, well, how many hours would you have to wait for this balance to accumulate 1.0 milligrams of dust on the weighing pan? Okay, so we have a weighing pan that has a diameter of 8 centimeters. So we're going to need to get the area because notice in the rate they gave us, it's tons per square mile per month, right? So if we write this out, it's 10. And notice the decimal there because that decimal means that zero is significant. So that's going to be important for when we calculate our answer and figure out how many sig figs we're allowed to have in our answer. So we have 10, and this is tons per mile squared per month. Okay? So this is what we have. They're giving us this rate, and they're giving us a scale with an area in centimeters, or when we calculate it, we're going to have to find the area in centimeters. And also we have this in months, and so um, we want the time in hours. So we're going to have to convert some of these units so that way we get a rate that's different. Now, the way that I'm going to show you in this video may not be the same way that other people might do it. There's multiple different ways of probably solving this problem or ways about going about it that leads you to the same answer. If you have a way of solving this that you think is easier or quicker, put it down below in the comment section. Let me know what that strategy is. Okay, so my strategy, excuse me, is to change the units here to the units that they want. So, for example, they want the time in hours, and I have month. So I'm going to change that to hours. They're giving me the diameter of the weighing pan in centimeters. I can use that to find the area of the circle in centimeters squared. So if I could change that to centimeters squared, that would be helpful. And they give me 1.0 milligrams of dust, but here I'm looking at tons of dust. So I'm going to change that to milligrams. So if we rewrite this in this way, right? So per 1 month per 1 mile squared, then what I can do is I can use conversion factors to change the top part to milligrams, and the bottom part, I have 2 units here. I can change each of those to hours and centimeters squared using conversion factors. So let's go ahead and do that. So I'm going to start with the top. And so tons, this is not a metric ton, this is an English ton. So 1 ton is equal to 2,000 pounds. So I'm going to put ton on the bottom. So 1 ton, and then on the top is 2,000 pounds. And I want to get to milligrams, so I'm going to have to keep going. So tons cancel out. Now I have pounds. And again, there's several ways you can go about converting to milligrams. You can convert pounds to ounces, or you can convert pounds to grams or kilograms. It doesn't matter which conversion factors you use as long as you're getting to the same unit and doing it in the correct way. And so what did I use? I used kilograms. So 1 kilogram is equal to 2.2 pounds. So I'm putting 2.2 pounds on the bottom, and I'm putting 1 kilogram on top. So pounds cancel out. Now that I have kilograms, I want to get to milligrams. So I'm going to convert kilograms to grams and then grams to milligrams. So I know that 1 kilogram is equal to 1,000 grams. So I'm going to put 1 kilogram on the bottom and 10 to the third, or 1,000 grams on top. So kilograms cancels out. Now I have grams. Now I can convert this to milligrams. And so milli is 1/1000th of a gram. So it's going to take 1,000 milligrams to equal 1 gram, or 1 milligram is equal to 1/1000th of a gram. Either way works. I'm going to use 10 to the negative 3 for 1/1000th of a gram on the bottom. So grams goes on the bottom. And I'm going to put 1 milligram on top. So grams cancels out. And again, you could put, excuse me, you could put 1 gram on the bottom and 1,000 milligrams on top, and it will give you the same ratio. So either way is fine. So now I have milligrams for the top, which is what I want because I have milligrams here. Now I want to convert these as well. So I'm going to convert month into hours. And here we're going to assume that 1 month is equal to 30 days, a lunar month, right? So we'll convert month into hours. So first, if we're saying that 1 month is 30 days, we're going to convert that to days. Since I have month on the bottom here, I want month on top. So I'm going to put 1 MO for month, and then 30 days on the bottom. So month cancels out here and here. Now I have days. I can convert that to hours using 1 day is equal to 24 hours. So again, I have days on the bottom here. So I'm going to put days on top. So 1 day, and then 24 hours on the bottom. So days cancels out. Now I have hours, which is what they're asking for, how many hours. So now that's done. And so lastly, I want to convert miles squared to centimeters squared. And so I'm going to have to do that. So when you have a square unit, when you do your conversion factor to convert from one length to the other, you're going to have to square that conversion factor. So I'll tell you what I mean. So miles, what do I convert to? I'm going to convert to feet. So again, you can convert miles to kilometers and then go that route. Here we're trying to get to centimeters. So however you convert miles squared to centimeters squared, doesn't matter how you do it as long as you're using the right conversion factors. It should get you the same answer. Oh, excuse me. Okay, here we go. So miles squared, I'm going to go from miles to feet. So I know that there's 5,280 feet in a mile. So I'm going to use that conversion factor. So I have miles squared on the bottom. So I'm going to put 1 mile on top and 5,280 feet on the bottom. So 5,280 feet on the bottom. Now notice this is miles squared, so I need square miles. So what I'm going to do is I'm going to square the conversion factor. So that's squared. So everything inside is squared. So I have now square miles and square feet. Also, the numbers have to be squared too when you do your calculation, but we can do that later. So then I'm going to multiply by another conversion factor. I'm going to carry on down here. So now that I have feet squared on the bottom, I'm going to convert feet to inches. So since I have feet on top, I have feet on the bottom, I'm going to put feet on top. So 1 foot on the top, 12 inches on the bottom. And again, I'm going to square that because I want square feet over square inches so that this will cancel out. So here, miles squared is going to cancel out with miles squared there. And now feet squared is going to cancel out with feet squared here. And now I have inches squared. So I need to get to centimeters squared. So one more conversion. I know that 1 inch is equal to 2.54 centimeters. So inches on the bottom here. So I'm going to put 2.54 centimeters on the top. Oops, sorry. So I have inches on the bottom. I want inches on top. So 1 inch goes on the top. And then on the bottom is 2.54 centimeters. And again, since I have square inches here, I need to square my conversion factor. And so now inches squared cancel out with inches squared, and now I have centimeters squared on the bottom, which is what I want. So now when I calculate this out, I'm going to get milligrams per month per centimeter squared. So when I calculate this out, all I need to do is multiply by everything on the top, being cognizant, being aware of the square. So I need to make sure I square everything for these. And then I divide by everything on the bottom, again, making sure I square these here on the bottom. And I get my answer. And that is going to be, when I look it up, 4.785. Let me check that again. 4.875. So 4.875 times 10 to the negative 4 milligrams of dust per 1 hour per 1 centimeter squared. Let me double check. 4.875. Yes. So now I have the rate in the terms that's going to make it easier to figure out how long it's going to take for 1 milligram of dust to settle and build up on a pan that has an 8 centimeter diameter. And I want 1 milligram of that. So here we go. So I need to know the area that I'm going to be building up the dust on. So I need to calculate the area of that pan. And we know that the area is going to be, of a circle anyway, the area of a circle is pi r squared. So the area of this circle, I'm going to write it over here. So the area is equal to pi r squared, where r is the radius. The radius is half the diameter. So I'm going to take a half of 8.04. So then the area is going to be pi times 4.00 squared, and that's going to give me, and I calculated that out to be, give me a second, 50.265. So 50.265 centimeters squared. Oops, I forgot to put centimeters here. Centimeters. Okay, so that's the area on which the dust is settling. And we're told here, we calculated here, that this is the number of milligrams per hour per centimeter squared. So notice that centimeter squared is on the bottom here, and I have an area of this amount centimeters squared. So if I take the area and multiply it by this, I can cancel out centimeters squared. So then what happens? I get 4.875 times 10 to the negative 4 milligrams over 1 hour per 1 centimeter squared. If I multiply this by, oops, I don't need that line. If I multiply it by this, well, maybe I can put the lines there. So 50.265 centimeters squared over 1, no unit down here, it's just over 1. So then centimeters squared cancels out with centimeters squared. And when I calculate that, I get 0.02450. So 0.02450 milligrams per hour. Per 1 hour. So this is the amount of milligrams that are going to settle on that area per hour. Okay, so now I have a conversion factor. I can use this to convert milligrams into hours. How many milligrams? So they're telling me I need, we want to know how long is it going to take to put this mass, 1.0 milligrams of dust, onto the area of that dish, that pan. Well, we already got the mass, or the rate here. This is the rate per hour of the milligrams that is going to be added to that dish in that amount of time. So I can use this as a conversion factor to convert 1.0 milligrams to hours. So now I take 1.0 milligrams, that's what I want on the pan, and I want to know how long is that going to take. Well, use the rate, milligrams per hour, this many milligrams per hour. So I'm going to use that as a conversion factor. Milligrams is on the top, so I'm going to put 0.02450 milligrams on the bottom, 0.02450 milligrams on the bottom, and 1 hour on top. So milligrams cancels out. I have hours. So now all I need to do is calculate the number of hours. So I take 1.0 divided by this, and when I do that, I get 40.80 hours. So this is the amount of time it will take for 1 milligram of dust to settle and build up on the pan. Okay, so now we have to go to sig figs. So we've been multiplying and dividing. So remember, the rule for sig figs, when you multiply and divide, is that your answer should have the same number of sig figs as the least number of sig figs in all of the measurements that you have been multiplying and dividing. So let's go back to our calculations here. So we have 2 sig figs here, because remember, that decimal point tells us that the 0 is significant. So we have 2 here. This is an exact relationship, so we can ignore that. Here we have 2 sig figs. This is exact. This is also exact. Here we're taking this as exact. 1 month is exactly 30 days. 1 day is exactly 24, so that's exact. 1 mile is to 5,280 feet. That's exact, so we can ignore that. Anything exact, we can ignore. 1 foot is 12 inches. That's exact. 1 inch is 2.54 centimeters. That, if you didn't know that, that's exact too. That's true by definition. So we have this one and we have this one. They both have 2 sig figs. So our answer should have 2 sig figs. So notice here, when I calculated this, right here I have 3 sig figs. So this answer here, I'm only allowed to consider 3 sig figs. 1, 2, 3. But I kept the rest of it because I don't want to round too early. If you round too early, you're going to get a rounding error, because I'm going to use this later in a calculation. I don't want to round it and then reuse it in a calculation and then have to round that answer. Then you compound the rounding and you make a rounding error. So I'm only allowed 3 sig figs here, but I take all of it and I multiplied it. So this technically has 3 sig figs. This has 2. Notice I'm keeping all the digits here because, again, I don't want to round too soon. So now, again, so the least number is still 2 sig figs. So this answer here should have 2 sig figs. And then I take this has 2 sig figs. And again, this has 2 sig figs. So once more, this answer should have 2 sig figs. So I need to round this to 2 sig figs. So the 4 and the 0, cut it off there. This is an 8, which means that I round the 0 to a 1. So my final answer is 41 hours. So it takes 41 hours to build up enough dust on that weighing plate, on that weighing pan, to get 1.0 milligrams of dust. So that's it for this video. I hope this was helpful. If it was helpful, if you enjoyed this video, then please like the video, share the video, hit that like button. Also, make sure that you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you'll be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, then please put that down below. If you have a problem or a question you need help answering, put that down below. I would love to do that for you. And again, if you have another way of solving this that you think is easier or quicker, put that down below. I would love to get that from you. Thanks for joining me and have a great day.